Hello all. In this video we are going to see the counters and its applications. Counters. What exactly the counter means? Counters are the sequential circuits. As we know, sequential circuits, its present output is depends upon the present input as well as the present state. So these counters can be implemented using the flip-flops. So as you increase the number of flip-flops, the counter value will be increases. For example, if you are using a one flip-flop, you will be having the two states, that is 0 or 1. If you are using two flip-flops, you will be getting the four states. Similarly, if you are using the n flip-flops, you will be getting the 2 power n states. If you want a counter with a more value to count, then you have to go for a more number of flip-flops. Now, what are the different kinds of counters are available? We can see those are the two types of counters are available. One is synchronous counter, one more is asynchronous counter. Let's see what is the difference between the synchronous counter and asynchronous counter. Synchronous counter, the name itself says synchronous means all the flip-flops in the counter should be having the same clock. Here you can see in this example we are using the two flip-flop 0 and flip-flop 1. Both the flip-flops are applied with the same clock. So as soon as you will give the input, as soon as the clock comes in, the both the flip-flops will start executing the output. So there is no delay in getting the output. And the synchronous counters are used for generating any kind of sequence. Either it can be up, either it can be down. Any random pattern also be generated with the help of the synchronous counters. The example for the synchronous counters are the Johnson counter, ring counter, and many others are there. Next we see asynchronous counter. As name itself suggests, asynchronous counter. Here means the same clock won't be applied to all the flip-flops. Here we can see one example. Here we are taking the two flip-flops. In these two flip-flops we are giving the external clock to only one flip-flop. The second flip-flop clock is depending upon the output of the previous flip-flop. So whenever even the data is available to the second flip-flop, until there is a clock, it won't do any processing. So we can straight away we can see that there is a delay. So by this we can say that the synchronous counters are the faster than the asynchronous counters. And one more thing is, like, with the help of the asynchronous counters you can only count a fixed sequence possible. It is like either you can go a up counter, it can be a down counter. You can't do any random kind of counting like 1 2 3 3 2 2 2 2 5. These kind of counts are not possible with the help of the asynchronous counter, but this can be possible with the help of the synchronous counters. The example for the asynchronous counter is a ripple counter. And we can see one example how counter is used as a frequency divider. As we told earlier, if you are using n flip-flop, you will be getting the total 2 power n states. So in these 2 power n states, you may not be using all the states. Sometime you may be using all the states. So if you are using all the states, then the modulus is nothing but the number of states you are using. So if you are taking a 10 flip-flops, you can get maximum of 1024 states. Out of that, if you are using only 1000 states, then the modulus of that counter is 1000. So here is a one small example. If you are having a frequency f, if the counter mod is n, the output frequency will be f by n. So this is like reverse engineering. If you want to implement a 1000 mod counter, then how many number of flip-flops you require? That is nothing but the log 2 base n. This will give the answer to you. And here is the applications of the flip-flops. As we see, to count the number of clock pulses applied, used as a frequency dividers, timers, waveform generators, frequency measurements, pulse width measurements. These are the applications of the counters. So we can see one real-time example, like if you consider a communication scenario, you want to know the how many bits of information is sent from the transmitter to receiver. So here also you can take help of the counters. It is like you increment a counter value by 1 whenever you are sending a 1 bit of information to the receiver. So at the end of the transmission you can see how many number of bits you have transmitted by seeing just the count of the counter. So one more thing is, like, you can see how many steps it has been performed for the some computation, or else you can see how much time it took for that computation. If you see that these many number of clock pulses are required for completing this application or completing this particular task. With the help of those number of clock pulses, you can calculate the time how much it is required. And in many all our processes, we will be having the one counter called the program counter. This program counter stores the address of the next instruction to be performed. This is all about the basics of the counters and what are the different types of counters, what are the applications, what is the main difference between them. And in next video we are going to see the implementation of the synchronous and asynchronous counters. Thanks for watching.